In this example, we're going to look at polynomial division from a different perspective. Instead of giving you a polynomial and the monomial that you're dividing by, we're going to give you pieces of the polynomial that you started with, an unknown monomial that you're dividing by, and pieces of the result. Our job is to fill in the missing exponents and coefficients from each equation. Once we've done that, we will then rewrite the entire equation with everything filled in, so it is a complete statement. So in the first example, we have 20y raised to some power minus 16y raised to some power plus something times y to the fifth, all divided by some monomial, something y to the something, and in the end we know that equals something y to the seventh minus 4y to the third minus 3. Now at first it might seem a little overwhelming. We've not been given enough information, specifically because we don't know what we're dividing by. But our first step in answering this question is to figure out what was it that we divided by. Now one thing we can take for granted is that the first term in the original numerator, 20y to the something, after it's divided by the monomial, does become the first term in the result, something y to the seventh. Similarly, negative 16y to the something divided by that monomial did become negative 4y to the third. And finally, that something y to the fifth divided by, well, we don't know what's in the denominator, did become negative 3. We can take for granted that the order the polynomial is written originally will match the order of the result on the right side of the equation. If those were able to be mixed up, then there'd be no way to answer this question. So the way to begin this is to recognize that in all polynomial division, what happens for coefficients is separate from what happens with the exponents. So as we try to figure out what happened here in this equation, we need to start either by first finding the coefficients or finding the exponents, but to separate that into two separate components. So let's begin with the coefficients. The original first term in the numerator had a coefficient of 20, but I don't know what I divided that 20 by, and I don't know what I got as a result. There's not enough information to tell me what the coefficient of the denominator is yet. If we look at the middle term, we have negative 16 as a coefficient. I don't know what I divided that by, but I do know that the result was negative 4. That right there is enough to tell me, well, negative 16 divided by 4 equals negative 4. So the coefficient in the denominator has to be a 4. Now that I know the coefficient in the denominator is a 4, I can go back to the first term. 20 divided by 4 would give me a resulting coefficient of 5. And I can look to the third term. What divided by 4 would give me negative 3? Well, I know negative 12 divided by 4 equals negative 3. So by looking for the one term that has both a starting coefficient and an ending coefficient, I can first figure out what I had divided by, and then backtrack and fill in the other missing coefficients. Separately, we'll use a similar process for the exponents. But if I start at the first term had 20y to the something. I don't know what the exponent was. I divided by some power of y, but I don't know what the exponent down there was. So not knowing where I started or what I divided by doesn't help me figure out anything that's going on. Similarly on the second term, I have y raised to some power. I'm going to divide by y raised to some power. Well, if I don't know either what I started with or what I divided by, I can't complete that step. When I look at the third term, it started with y to the fifth. I don't know how many y's I divided by, but I do know that I don't have any y's left in the answer. The only way to start with 5 y's and divide by y to some power and not have any y's left over is if I had divided by y to the fifth. Y to the fifth divided by y to the fifth would give me a 1, and I wouldn't write that 1 down. I would simply leave it as there being no y's in the answer. Now that we know the denominator had a y to the fifth, or the exponent on the y in the denominator was 5, I can work backwards. Going back to the first term, I don't know how many y's I started with, but I know when I divided by y to the fifth, I ended up with y to the seventh. So what power of y would I have started with so that y to some power divided by y to the fifth equals y to the seventh? Well, I know I would have had to have started with y to the 12th, because if I started with y to the 12th divided by y to the fifth, that would have canceled out 5 of those 12 y's, leaving me with the 7 that I had in the end. Similarly in the middle term, I don't know what power of y I started with, but I know when I divided by y to the fifth, I ended up with y to the third. So I can work that backwards. How many did I have to start with so that when I divided by y to the fifth, I ended up with y to the third? Knowing that the division's really canceling out y's, I know I would have had to start with y to the eighth up in the numerator, because y to the eighth divided by y to the fifth is y to the third. So from what we have on paper, it looks like we filled in every missing exponent or coefficient. The way to finish this problem is, one, to rewrite the entire equation with those missing exponents and coefficients filled in, but as we do so, to double check our work. So what we think the numerator is 20y to the 12th minus 16y to the 8th minus 12y to the 5th. And if I were to take that 20y to the 12th minus 16y to the 8th minus 12y to the 5th and divide by 4y to the 5th that we came up with for the denominator, I'm not actually going to look at the answer that I had on the original problem where I wrote down my scratch work. I'm going to carry out this division. 20 divided by 4 is 5. Y to the 12th divided by y to the 5th is y to the 7th. Negative 16 divided by 4 is a negative 4. Y to the 8th divided by y to the 5th is y to the 3rd. Negative 12 divided by 4 is negative 3. Y to the 5th divided by y to the 5th would cancel out completely. So we've just set up the division problem to carry out, and we carried it out. Now we can double check that everything over on our answer side matches with what we came up with from our original work. In our initial attempt at this problem, we had decided that the right side had to be a 5y to the 7th, and that is exactly what we got over in our answer. The minus 4y to the 3rd minus 3 was given in the original problem, and that still matches what we got in our division problem. So we've now rewritten the entire equation like we were asked to do, but we've also checked our work to make sure the work does carry out as it should.